Hello y'all, and welcome to part 1 of lesson 5.6, where we're going to review inequalities and mostly just do a very quick overview of what you would have learned last year. There are 5 inequality symbols: a greater than or equal to, less than or equal to, and then a not equal symbol. Mostly we'll just use the first 4, but that not equal symbol is an inequality symbol. So the greater than looks like that. Greater than or equal to has a line underneath. The less than symbol looks like that. And less than or equal to has a line underneath. Not equal is just an equal sign with a slash through it. So for each of these inequality symbols, I also gave you an algebraic statement in that next row. And what I'd like you to do is write each solution as a sentence. Come on back and see how you did. Here's our first one. The solution is x is all numbers greater than 3. Our next is x is all numbers greater than or equal to -5. X is all numbers less than 0.25. X is all numbers less than or equal to -10. And lastly, x does not equal 5. When we find a solution to an inequality, we're going to be asked to graph it. And a solved inequality can be thought of as the boundary point between what numbers make an inequality true or not. So, for example, if I said x is less than 3, then 3 would be my boundary point, and all numbers that are greater than 3 would not make this a true statement. All numbers that are less than 3 would make this a true statement. When we are graphing inequalities, the boundary point is represented by a point on a number line. A closed point, like this, means that that boundary is included in the solution set, meaning that would be our less than or equal to and greater than or equal to statements. An open point means that a number is not included in the solution set. So that is just our less than and greater than. So if I wanted to graph this example right here, where we have x is less than 3, I could set up my number, and then I would plop an open dot at 3 and say that my solution is all numbers less than 3. So what we have here are 2 one-step inequalities, meaning you can solve these in one step. I'm going to solve the first one, and then I would like you to try to solve the second one without my help. So I'm still going to set up my t-diagram, and then I'm going to divide both sides by 12. What I come up with is g is less than 4. Now the checks are a little bit different. Since my solution actually means that g can be all numbers that are less than 4, I want to pick a number other than 4 to check that it makes a true statement. So I'm going to just pick 0 because 0 is less than 4. And I'm going to say, well, is 12 times 0 less than 48? And it's true that 0 is less than 48. That's a true statement, so my check is done. I could have also tried 1. I could say, is 12 times 1 less than 48? Absolutely. 12 is less than 48, so it's true. Okay, and then I'm going to graph this. Since 4 is not a part of my solutions, there's going to be an open dot at 4. Here's 5 and there's 3. And my solutions are going to be all numbers less than that 4. All right, go ahead and try it with this next one. Come on back and see how you did. So I got x is greater than or equal to 27. I'm going to go ahead and check with 30 just because that is one of the numbers that is greater than or equal to 27. So 1/3 of 30 should be greater than or equal to 9. And it's true that 10 is greater than or equal to 9. So I'm going to graph this. I know it's going to be a closed dot at 9. Oh, sorry. Nope. At 27. And then, so here's 28 and here's 26. You always want at least 3 data points on your number line. And then my solution is all numbers greater. And what kid pointed out to me once that the arrow at the end of your line matches your inequality statement. And I just thought that was kind of cool. Okay, so your next steps, I know this was pretty quick, and this is basically a whole 6th grade unit in one tiny lesson. So if you want more practice, if you head on over to my Canvas homepage and you look for this unit on one-step inequalities, it's just a little Khan Academy unit, and you can click through it and try some of the practice stuff. If you're ready for 2-step equations, then go ahead and just watch the next video.